Let me just go back to what an animal systematic review would look like. I just told you that these are actually quite rare. They happen to be looking at a stroke drug. And these reviewers created a 10-point scale to try and give some quality assessment to the animal experiment. Only one, blinded therapy. Two, blinded assessment. Actually, 3 of these studies got 0 points on this quality scale, and the maximum score was 7. And this is a very typical result from going into a body of literature from the animal research and trying to assess the quality of the study. And we also see this. When you rank the quality of the studies, and these renders are the worst, these are the best, against the effect sizes, worse, lower quality studies producing the larger effect sizes. And we see that time and time again in doing these kinds of analysis. Looking at trends over time, the blue is randomization, and you can see an improvement in the more recent studies after 2006, but still it's less than a third of these studies are being randomized. I want to talk about bias. 235 biases were identified in 17 million PubMed papers. I always thought there were only about 50. To just show you how one bias can actually, I'm picking 3 samples, can have a significant effect. So that's recall bias. We're going to look at that. And this is, I would say, an infamous meta-analysis of asking the question, if a woman has a prior-induced abortion, does that increase her risk for breast cancer? This meta-analysis is actually still being used in some state houses to limit reproductive choice. But this is what a Danish study found, they were all case control studies, who didn't do cases, they actually did record linkage. 1.5 million women linked between induced abortion and breast cancer, relative risk of 1. What happened here? Why was it inflated risk? Well, you've got to think about how you do these studies. You're asking women with breast cancer about their previous pregnancy history, and they're likely to tell you everything. And then you're asking often a healthy control group of women about their pregnancy history, and they might not tell you all about their previous induced abortion. So you get the inflated risk in cases. Some people did this correctly. Dr. Brinton from NCI did a wonderful case control absolutely nailed it there. Get some of these results. These are wildly high risk estimates, even one protective effect there. So that's how one bias can function and influence a body of literature. Here's interviewer bias. And this is a meta-analysis looking at the question, does residential EMS increase risk for childhood leukemia? We've got the studies here, the high-quality studies suggesting no substantial increased risk. The lower quality studies down here suggesting increased risk. And the first study in this whole body of literature was this one, Wertheimer and Luther. This is a study that closed schools in California. And the interviewer bias comes in because these studies were done looking at wire coding, the thickness of electric power lines into the house, how close to the house were transformers. And these were all estimated by interviewers, who in this study knew if the house was the home of a child with leukemia or the house of a control group. And so, whereas these studies tried to manage that sort of bias, this study, which had a big effect in terms of creating a major public health scare, didn't manage to do that. The third example I want to use is channeling bias. Channeling is a form of bias by indication. And bias by indication in pharmacoepidemiology, of course, is the drug that you're worried about causing the outcome that you're interested in, or is it actually the disease that the drug is in? So this is looking at the question of congenital cardiac defects.